Dedicate one to the ladies. Summertime sit back, need something to keep you cool.
Salty caramel ice cream includes sugar and also salt. How do chemists know the formula of sugar? Or the chemical formula of salt? And how do chemists determine and describe the chemical transformation of substances?
Hold on a second, baby.
Go to the lab.
At the lab, chemists perform experiments and make observations. Observations are macroscopic, what our senses see, hear, or feel. Examples of observations are color changes, gas evolution, or a change of temperature. In this example, there is a color change due to a pH indicator and heat being evolved. Chemists also make inferences, which are logical conclusions based on observations. For example, based on this conductivity test, the chemist may infer the presence of ions in the solution. Notice how, when your textbook describes a conductivity test, the observation, the light going on, is separate from the inference, the presence of ions in the solution. Here the observation is magnesium metal being added to acid with the gas being evolved. The inference is shown in the diagram depicting what the particles are doing, or it is shown symbolically in the chemical equation. Here is another example. The observation is the flame. The inference is a combustion reaction. Notice how it can be shown in terms of the particles or with a chemical equation. Methane is combining with oxygen to form carbon dioxide and water vapor. In this balanced chemical equation, the stoichiometry is also shown. That is the relative amount of the reactants that are combining to form the products. The purpose of today's lab is to investigate the chemical reaction of lead nitrate with potassium iodide. You will make observations, draw inferences, determine the pattern of reactivity, and the chemical equation. You will express the chemical equation by sketching a particle representation and also symbolically. In Part A, you will record your initial observations in your notebook when lead nitrate is combined with potassium iodide. You will find that a precipitate forms. But what is the composition of the precipitate? Your initial observations will later be transferred from your notebook to the report form. To determine your chemical equation, you need tests that can identify the anions and cations present. In Part B, these tests are introduced. The test for distinguishing between iodide ions and nitrate ions is to combine them with hydrogen peroxide and dichloroethane. You should expect the results to be different for each test. A testing procedure is also provided for the cations, potassium or lead ions. This test should be done in the hood. Once again, record your observations and they will be later transferred to the report form. At this point, you now have tests that can distinguish between the iodide and the nitrate, and also tests that can distinguish between the lead ions and the potassium ions. It is okay to discuss and compare observations with your classmates. In Part C, you will begin applying these tests to identify the ions that were in the precipitate. You will first isolate the precipitate by removing the supernatant, then test to see what anions it is comprised of and what cations. In Part D, you will determine a ratio of the ions in the precipitate. To accomplish this, take 5 different 4 milliliter test tubes, and then, using the same medicine dropper, transfer different amounts of lead nitrate and potassium iodide to the different tubes. Notice you will construct tubes that have different ratios of lead nitrate to potassium iodide. With this information, you will be able to infer the chemical composition. This will involve observing the amount of precipitate that forms upon mixing, and then also testing the supernatant to determine which ions are in excess. In terms of laboratory safety, be careful to avoid burns. Since lead salts are toxic substances, be sure to wash your hands thoroughly. The solvent dichloroethane is a suspect carcinogen and may be irritating, so use caution. And finally, when testing for cations, it must be done in the hood. When disposing of waste, all solutions containing lead ions and dichloroethane must be collected in a beaker at your desk. Neutralize the solution with sodium hydroxide, add it to the inorganic waste beaker in the hood, and fill in the waste disposal sheet. What is the key to succeeding at this lab? You must connect your inferences to your observations. Suppose you are asked to determine the empirical formula for sodium chloride. Support your reasoning and make it so that a baby could understand. A student might state that the formula is NaCl, and their reasoning is that sodium is a +1 cation, chloride a -1 anion, and therefore it combines to form NaCl. This line of reasoning would not be satisfactory and may even distress the child. Why is this unsatisfactory? The reasoning is not tied to any observation and only works if you already know the answer. What were the observations? What were the inferences? Convince the reader that you know what you're talking about.
Come on and meet the elements. May I introduce you to our friends, the elements? Like